Welcome to Ask and Learn.
All right, so the domain for this one is x has to be greater than -1, so we can keep our argument positive. And for intercepts, we have 0, 0, so the origin. Symmetry, we have none. No symmetry. Asymptotes, we have 1 at x equals -1. All right, because our domain cannot be negative numbers because of the natural log. So that's why we have an asymptote there. All right, and next up we have to find increasing and decreasing intervals. So y prime equals 3x squared over 1 plus x cubed. Set that equal to 0. We have x equals 0 is one of our critical points. All right, so first derivative test. So this is f prime. Its test points around 0, our critical point, and we see that it's going to be increasing always. Okay, so our function is always increasing. And if we find our second derivative now for the concavity test, y double prime equals 3 times 2x minus x to the fourth all over 1 plus x cubed, and that's all squared. Set that equal to 0, and we come to two critical points. X is 0, and x equals the cube root of 2, which is approximately 1.3. Okay, so second derivative test. So f double prime. So this is 0. This is the cube root of 2. We have concave down. Oh my god, that's concave down here, concave up here, and concave down again. Okay, so these are both inflection points. And just so we know, the y value, so f of the cube root of 2, the y value is going to be ln of 3, so that's approximately 1.1. All right, and then that's just so we can graph it later. So let's keep all of that. Over here. And now we can graph. So we know we have an asymptote. Let's put that in green. It's going to be at -1. So this is -1. We have a vertical asymptote here. We have an intercept at 0, 0. We have, it's going to be concave down until it reaches 0. So concave down until it reaches 0, and it's always going to be increasing. And then once it reaches 0, it's going to be concave up until it hits our inflection point. So let's say this is 1.3. So this is, if this is 1, 1.3 would be about here. And then if this is 1, 1.1, 1.3. So let's say right there. So that's our other inflection point. So it's going to be concave up until it hits our inflection point, and then it will be concave down the rest of the way up.